Hello everybody, Mr. Keeney here again. We're continuing our Unit 2, which is about angle relationships and logic. So we're today going to continue, like I said, that, not only that, but also our algebraic proofs, and we're going to bring in a couple properties, some new reasons that we can use when we're making our statements and reasons for our algebraic proofs, which will transition eventually into our geometric proofs. So remember, the learning target kind of for this whole unit is we're using this deductive reasoning that we've talked about to form a logical argument. So for today, we're going to put a little bit or a couple more tools in our toolbox when we are making those logical arguments. First one up is the reflexive property. The reflexive property, and you'll see here, it works for real numbers, segment length, and angle measure. What the reflexive property says is for any real number a, the reflexive property says a equals a. A number a equals itself. And so for us in geometry, another useful thing for that is segment length. For any segment length AB, any segment AB, the length AB is equal to AB. And for any angle measure of angle A, we know the measure of angle A will be equal to the measure of angle A. So the reflexive property here, it says that something is equal to itself, which is kind of important. I know it might seem, kind of basic or something that we knew already, but one, this gives us a justification for knowing that. And at the same point, remember the addition property, subtraction property, multiplication, and division property, we have to add the same thing to both sides. So now this establishes that something is equal to itself. So when I add, let's say 3 to both sides of an equation, I know I can do that because 3 is equal to 3. So that is the reflexive property. You will always hear me say reflexive if you have me in class, and if you have me online, hopefully you'll hear me say this too. Reflexive repeats, and by repeats, on either side of the equation, I'll have the same thing. So A and A, AB and AB, measure of angle A, measure of angle A, reflexive repeats. The next one is symmetric property, and you can think symmetric as symmetry. It says for any real number A and B, if A equals B, what I can do is say that B equals A. I can switch it. So if A equals B, B equals A. And this again works for segment length. So if AB equals CD, I can switch those and say CD equals AB. And then also for angles, angle A and B, if I say the measure of angle A equals the measure of angle B, so I can say the measure of angle B equals the measure of angle A. So reflexive repeats, and what you'll hear me say about symmetric switches. So symmetric switches. It switches either side. So it was A equals B, now it's B equals A. And we see this. Sometimes we work out an equation and we get to like 1 equals X. And if you're like me, I like, just for not a good reason, but I like having X on the left-hand side. So we'll do this. The symmetric property allows me to switch sides. So there is our two new properties, reflexive property and symmetric property. Going down to transitive. Transitive is using 3 different real numbers, A, B, and C. If A equals B, and we also know B equals C, then what I can conclude is that A equals C. I always talk about shoes for some reason when I talk about this one. If I have the same shoes as, let's see here, I got to think of another teacher you guys might know. If I have the same shoes as Mr. Ballinger, and Mr. Ballinger has the same shoes as Mr. McElroy, then I can deduce from that that me and Mr. McElroy have the same shoes. And it works the same with numbers here. If A is the same as B, and B is the same as C, then I can say A and C are the same. And the same with looking here. I want to point out that B is kind of being like a middleman, CD is being a middleman. I'm going through these to say AB is equal to EF. So I'm using the relationship that they both have with CD. For any angle A, B, and C, it's the same thing. I'm going to use my relationship. They're both equal to the measure of angle B. So measure of angle A will equal the measure of angle C. So there's our 3 new ones. I'm just scroll up. We have the reflexive property, which repeats on either side, symmetric property, which switches, and then transitive property, which we're saying we're using that relationship. A is equal to B, B is equal to C, so A is equal to C. And now let's just do some examples to finish up these notes today. Identify the property that makes each statement true. So AB equals AB. This is repeating on both sides, AB and AB. So I'm going to say the reflexive, and then I'm also going to say property of equality. And it's equality because of the equal sign. If we ever see congruence, which we won't today, we're going to say POC. This one right here, if xy equals pq, then pq equals xy. They are switching, so that is symmetric. Symmetric, and then again, property of equality, because there's an equal sign. Measure of angle L equals measure of angle S. Measure of angle S also equals measure of angle N, so then I'm concluding that L is equal to N. The measure of angle L is equal to the measure of angle N. This one is transitive. So here's just some more examples. Those first three were just examples of things we just learned. I'll actually change color to make sure you know which one I'm on now. This one, number 4, it says if xc is equal to mb, then 4 times xc equals 4 times mb. And this 4, I'm multiplying the same thing to both sides. So that would be the multiplication property of equality. I'm multiplying the same thing on both sides. Let's see here. If the measure of angle h equals the measure of angle p, and the measure of angle h equals 3, instead of h, I'm going to put in its place 3. So 3 equals that. Now I'm using substitution. Substitution property. And with all these too, you guys can go ahead and pause if you want and try it on your own. I'm going to keep going on with these ones here. If I have GH equals XY, then I have GH minus 10 equals XY minus 10. I'm doing the same thing to both sides, so it's a property of equality here using one of our addition, subtraction, multiplication, addition, and we get subtraction because I'm subtracting the same thing from both sides, and this is property of equality. Measure of angle 1 equals the measure of angle 1. I'm repeating on both sides, so this is our reflexive property of equality. Reflexive property of equality, same thing on both sides. And then let's look at these last ones. HO is equal to RS, and RS is also equal to EY. So I'm going through RS to say HO is equal to EY. That is transitive property of equality. And just 2 more here. C plus D, the measure of angle C plus the measure of angle D equals 180. And then we're saying, okay, D equals 45 though. So instead of D, I'm going to put 45 in its spot. So this would be an example of the substitution property again. I'm subbing in what I know the measure of angle D is equal to, which was 45. So substitution property. And our last one here, 5 times the quantity x minus 1 equals 14. Then I have 5x minus 5 equals 14. And what they're doing is they're multiplying in, which we call that the distributive property. All right. So distributive property ends our examples here. And I'll just check. Yes, it does. So that is 2.5 day 2. So some more tools, some more properties in our toolbox to go along with a little bit of review from our 2.5 day 1. Thank you for watching. If you guys have any questions, please reach out, and I'll talk to you guys later.